So you've got a 30, 60, 90 triangle here. Your hypotenuse is 1. What does that make your short leg? 1/2, 1/2, exactly. Okay. And then what does that make your long leg? 3/6, okay. All right. 45, 45, 90. Hypotenuse is 1. What are both legs? 2/2. Okay. All right. Those are crucial when we figure out our unit circle. So all of those numbers should become very, very familiar. So you guys have to turn the page. Let's look at this circle. A lot of you guys did the unit circle last year. I'm not sure everybody did. No, no. Oh, did any of you? Okay, that's all right. I'll teach it as if no one's seen it. So, all right, first thing we're going to do is go all the way around our circle with degrees. Degrees are familiar to you right now, so that's what we're going to do. So 0 degrees is first. All right. Then the rest of them, they come from our special right triangle. So think about it. We have 30, we have 60, and we have 45. Which of those is the smallest? 30. So that's next. What do you think after that? 45. You guys, I'm going to color code mine. I know this is going to get annoying to switch. If you have colors and you like using colors, I would do that. And then after that would be 60. Can you guys see that green okay?
Yeah.
Yeah, okay. All right. Then what do you think is going to be up at the top? 90, yes. Okay, so the pattern that is happening here, from the axis, you travel 30 degrees, then 15, then 15, and then 30. Okay, so after 90, what do you think is going to come next? 120, and so that's going to be green for me. What about after 120? 135. After that? 150. Good. It's the color I want. 150. And then when we get back to the x-axis, 180. All right. So far, so good. What's going to be after 180? 210. So for me, that's going to be blue again. After 210, 225. After 225, 240. And then the y-axis down there, 270. Nice. All right, one quadrant to go. What's it going to be? 300. Good. 315. 330. And then we make it back to where 0 was. You can also say 360, right? That's all the way around. Okay? Not bad, right? Easy to remember the degrees all the way around. Okay, so now what we have to think about, we're going to do ordered pairs next. We'll do the radians as our last one. So this is a unit circle because your radius is 1 unit long. So if I'm on a normal XY plane and I'm 1 unit to the right, what is the ordered pair for that point? 0, 1 is up here. 1, 0. Yes? Okay. 1, 0. So let's label all of them that are on an axis. So 90 degrees would be 0, 1. What's 180 degrees? Okay. And down there at 270? Okay. All right, so those are easy. Okay, now let's think about our 30 degrees here. I'm going to sketch it in. You don't have to draw this triangle that I'm drawing. I'm just drawing it so we can see how this relates to our special right triangle. So this is where the 30-degree angle is, okay? We know the hypotenuse is 1. You just told me what the other two sides were. What's this little short side over here? 1/2, and what's the long side? Okay. Do you see how this is an x value and this is a y value? Okay, so your ordered pair is √3/2, 1/2. Okay. Are you guys with me on that? Long leg, short leg of a 30, 60, 90. Long leg horizontal, that's an X thing. Vertical things are Y's, right? Okay. So we're going to label all of these that I have in blue. Because you guys see how those are all just 30 degrees away from the x-axis? Okay, so they're going to have the same ordered pair except what's going to change? Signs, right? So when I'm over here in the second quadrant, what's it going to be? Negative. That's not a super confident negative. Yes, there's a negative. So the x is negative. Negative √3/2. Your y is still positive 1/2. Right? You went left and up. That's negative and positive. Yeah, so down there in the third quadrant at 210 degrees, what are we going to have? Negative, negative. Yeah, negative √3/2. Negative 1/2. And over there in the fourth quadrant. √3/2, negative 1/2. Okay? So if you know this ordered pair, you know 3 other ordered pairs. Just a second, make sure it's caught up with me. All right, so we're going to look at the 45-degree angle next, which is this 45, 45, 90 triangle, right? Your hypotenuse is 1, because this is the unit circle. What are both legs in a 45, 45, 90 triangle with a hypotenuse of 1? √2/2. So that's your x and your y. Okay, so √2/2, √2/2. So can you do the 135, the 225, and the 315 now? Yes, negative √2/2. 2/2. Both negative. Doing okay, guys? All right, so the next triangle is, instead of a 30, 60, 90, it's a 60, 30, 90. Okay. What is going to be different from the blue one that we did? They switch. Yeah, do you guys see how now the x piece is the short part and the y is the long part? Okay, so short part comes first, then the long part. So this is going to be 1/2, then √3/2. You know that? Can you do all the other quadrants? Okay, so negative 1/2. Okay, still have radians to do. So far, so good? Okay. So 30 degrees, if you converted that to radians, what would it be? How quick are you at your converting at this point? Yes, that would be pi/6. Okay, I'm going to do all the ones in blue, because again, they're connected. There's a pattern to them. All of those that are 30 degrees away from the x-axis, they are all something over 6. So this one's something over 6, something over 6, and something over 6. Okay, could you go through and convert every single one? Yes. That takes a while. So the pattern, what happens here is you're counting by like 1 over 6. So what we're trying to do when we get to this point, it's going to be the next over 6 that doesn't reduce. So this is 1 pi over 6. Then we'd have 2 pi over 6, right? But doesn't that reduce? Okay. 3 pi over 6. That reduces. 4 pi over 6 reduces. 5 pi over 6, that works. And guys, think about it. 180 degrees, we know that's pi, right? 6 pi over 6 would have been that one. So this one is 5 pi over 6. It's just before you get there. And then we keep going. So 5 pi over 6. Keep counting. 6 over 6 would reduce. What about 7 over 6? Okay, that's the one I want. 7 pi over 6. And then keep working around all the way to, what's this one going to be? 11 pi over 6. All right, so what's 45 degrees in radians? Pi over 4. So same idea. The next one over here, what do you think this is going to be? 3 pi over 4. Good. What about down here in the third quadrant? 5 pi over 4. And then over here, 3/15. 7 pi over 4. Good. All right, then 60 degrees. What is that in radians? Pi over 3. Okay, what's going to be right here then? 2 pi over 3. And guys, doesn't it make sense? These are pretty close together and we didn't skip any numbers getting there. Whereas like pi over 6 and 5 pi over 6, those are pretty far apart. We skipped a lot of numbers to get there. Okay, so this is 2 pi over 3. What's it going to be down here at 240 degrees? 4 pi over 3. Good. And then the last one? So then all we have left are the ones that are actually on the x and y axis. From converting, we know 180 degrees is equal to pi, okay? So 90 degrees is half of 180, right? So what's the radian going to be up there? Pi over 2. What do you think down at 270? Pi over 2. And then all the way around is 2 pi. Okay, next class, you guys have a quiz on this unit circle. Okay, I will give you a blank one. You have to fill in all degrees, all radians, all ordered pairs. You'll have 5 minutes to do it. 5? 5 minutes. You can. I promise you can. 5 minutes. Guys, I would practice. I don't see you again until Tuesday, right? So over the weekend, like, just draw a circle and see if you can label it. And this isn't just, I mean, you can obviously just memorize the whole thing, but if you can think about the patterns and what's happening, it doesn't take you very long. Okay, if you know these ordered pairs, you know all the ordered pairs. All right. Okay, so just know that's coming. We're not done with notes yet, but know that's coming, okay? All right, so let's do a little bit with these. Go ahead and turn the page in your notes. Just full of cheesy math. All right, so now we're going to do sine, cosine, tangent, secant, cosecant, and cotangent within this circle. So we're going to draw a little triangle over here. That's a theta, T-H-E-T-A. Okay, we use a lot of Greek letters for our angles, so we get used to those. All right, so I'm going to label that X and Y. Does that make sense to you, why I picked X for the horizontal, Y for the vertical? Okay, excellent. And then my hypotenuse, I'm just going to call R because it's the radius of my circle. The circle we just made, your radius was 1, but these will work on a circle with any size radius, okay? All right, so we're going to set up our trig ratios here. So sine of theta. Sine of that angle, what do you think that is? What? Y over R? Okay, yep, no, that's fine. Y over R, good. What about cosine of theta? Just say it, guys. X over R. Tangent of theta. Over X, good. Okay, then the ones you guys are less familiar with, cosecant of theta. R over Y. Secant of theta. And cotangent of theta. Oops, sorry guys. All right, now down here, because what we're focusing on right now is the unit circle, what are all of the R's in those little equations? They're just 1, okay? So that means the sine of theta is really equal to just what in the unit circle? Y. Okay, yeah. The cosine of theta is just, yes. Tangent of theta, you still have to use both. It's Y over X. Okay. And this is just a little joke for you if you're trying to remember. Tangent, that's a tangerine because it's a sine-gerine over its cosine. All right, so let's actually use a few of these. So, what we're doing now is thinking about the unit circle we just created, and you guys can flip back to it right now because I know it's not solid in your brain just yet. So if I want the sine of 3 pi over 2, okay, sine means y value, so you go to 3 pi over 2, and what is the y part of the coordinate? -1, right? That's it. So again, all you're doing, you're finding your circle here. Here's 3 pi over 2. Sine means y. -1's my answer. Okay? Let's do another one. So number 4, cosine of 5 pi over 4. Is cosine x or y? x. All right, so go to 5 pi over 4. What do you think? Yes, negative root 2 over 2. All right, and let's do 5 together. So sine of negative 4 pi over 3. Okay, this is trickier. So let's think about, on your circle right now, here was pi over 3, right? And then it was 2 pi over 3, 4 pi over 3, 5 pi over 3. This is asking me to go negative 4 pi over 3. What does the negative tell me? Which direction am I going now? Yeah, clockwise. So that means this is negative pi over 3. Can you see that down there? So 4 pi over 3, well, that's the same as negative 2 pi over 3. You guys see it? We're just traveling backwards, but you're going the same distance. So this is negative 4 pi over 3, and up here pi over 3, that's negative 5 pi over 3. You guys with me? Just going backwards around the circle. Okay, so what is the, sorry, I forgot what it was asking. Sine of negative 4 pi over 3, what'd you say? Root 3 over 2? Yes. Okay. So first, do you understand that negative 4 pi over 3 is the same spot as 2 pi over 3? Okay. So, yeah, so the right triangle, you always draw the right triangle. So it goes back to your reference. So,
okay, it's always
yes. All right, guys, figure out, work on the rest of these 6 through 14 before we go to lunch here, okay?
Totally. True.
How are we doing, guys? Talk to your neighbors, see if you're doing well.
Pi over 24, a little less than 180 degrees, right? So, a little less than 180, like let's say here, hypothetically. And this point is a tiny bit less than more than also a little, this point is a little bit higher than the other. Right here, the negative one a little bit higher than the other one. A little bit very steady, a little bit higher here than there. You know, there's a person for standing.
All right, guys, and they're not sending costs. Okay.
But the jokes don't work.
Okay, guys, let's go through these. So number 6, everybody together. What'd you get for sine of 7 pi over 6? Okay, that was a little less enthusiastic than I was hoping for. What'd you get for sine of 7 pi over 6? -1. Yeah, there we go. -1. All right, cosine of 330. But I think you said root 3 over 2. Sine of negative 270. Cosine of pi. Sine of 11 pi over 6. Tangent of pi over 3. There we go. Tangent of pi over 2. Yeah, you get 1 over 0. That's not okay. All right, then without a calculator, sine of 23 pi over 4. I heard a lot of good discussions on this. 23 pi over 4, that's almost over there at pi, right? Because 24 pi over 24 would be 1 pi. So you're really close here. You're almost to that -1, 0, but not quite. So the sine, the y value, what's it really close to? Yeah, so just tell me almost 0. Oh, 5 minutes. I know, I'm really hungry. Okay. Then the cosine over there, what's that going to be really close to? Almost -1. Okay, does that make sense? All right. And guys, to help you out with the tangent ones, those are the ones that take a little longer, right? Because you have to think about y over x and sometimes rationalize. So let's look at our ordered pairs here. So any of them that are at the over 4s, right? Any of the pi over 4s, the tangent of those are easy. What are they going to be? What's root 2 over 2 over root 2 over 2? Just 1, right? So tangent, anytime it's over 4 is easy. It's 1 or -1. Okay? The pi over 6s and the pi over 3s are the trickier ones. You did a pi over 3, which was root 3 over 2 over 1/2. You flipped and multiplied, and you get just root 3, right? So this is tangent pi over 3. Anytime it's an over 3, like pi over 3, 2 pi over 3, 4 pi over 3, 5 pi over 3, you have to figure out positive or negative, but it's always just root 3. So if that starts to become familiar to you, you don't have to go through this work. And let's look at tangent of pi over 6, because that's the messy one. That's going to be 1/2 over root 3 over 2. So 1/2 times 2 over root 3. So that's 1 over root 3. Rationalize, what do you get? Root 3 over 3. So anytime it's an over 6, it's a root 3 over 3. Easy way to remember this, 6 is 3 plus 3, right? Whereas this 3 is 3. It helps your brain wrap around that at all. Okay? All right, guys, we've got just a couple minutes before lunch. Oh, do you have a question?
Yeah, for the questions where it's like asking for a sine or a cosine of a over 4 how, like, what's the reason?
So that is why we have, like, that's why the unit circle is so helpful, because you can actually talk about the distance, okay? Because you're looking at the ordered pair that goes with that. We're going to graph sine and cosine later, and it is 0, it is 1. You know, it's, you can't draw the triangle there to figure it out. You can't, no, because, yeah, you're just looking at the coordinate, the x and the y, okay? Yeah, because if you try to draw a triangle, it's like, well, the hypotenuse is the same as the y, and that doesn't work. So yeah, you can't actually draw the triangle. Anything else before lunch? Okay, when we get back from lunch, we're going to do a couple things. I'm going to give you just a practice one of the unit circle quizzes so you can see what you know. So don't like panic and study at lunch or anything like that. You don't need to. Just see what you can remember and see how long 5 minutes actually is. Then we're going to do some practice with trick dice where you'll be with a partner just evaluating all the different functions. Okay? But we won't start that after lunch. So again, guys, if you want your phones for lunch, that's fine. You are welcome to grab them. Just put them back when you come back in the room. last. So just a heads up.
things like that all the time.
And then my brother's like really close friends with his brother. Like his date is married.